Hi everybody, it's Robert at graspcast.com with another video for you to enjoy. Thank you for watching my show. Today's video is on distribution transformer basics. This video is primarily intended for power linemen and others who may be working in the electrical industry. We'll be talking about transformer components and their function, turns ratio, single-phase transformer, transformer polarity, transformer voltage, Transformer-KVA, and secondary windings. The transformer consists of a few simple components. We have a primary winding and a secondary winding. They're wrapped around a steel core. Notice that the windings are electrically isolated from each other. When voltage is applied to one winding, an electromagnetic field is created. The field magnetizes the core, and a voltage is induced in the opposite winding. The amount of voltage is determined by the number of turns in each winding, called the turns ratio. One way to determine turns ratio is to divide the number of primary turns by the number of secondary turns. In this case, 360 divided by 36 gives us a turns ratio of 10 to 1. We could also use the nameplate voltage data to determine the turns ratio. In this case, 120 volts divided by 24 volts would give us a turns ratio of 5 to 1. The single-phase distribution transformer has one primary winding connected to H1 and H2. The secondary side of the single-phase distribution transformer has two windings connected to the X1, X2, and X3 bushings. Note that each of the secondary windings are joined together on the X2 bushing. Distribution transformers can be either additive polarity or subtractive polarity. This is determined by the direction on which the windings are turned around the core. Externally, the X1 and X3 bushings are in different places for each of the polarities. X1's on the right, X3's on the left on additive polarity. X1's on the left, and X3's on the right for subtractive polarity. Polarity becomes important when banking transformers together. On a side note, by industry standards, single-phase distribution transformers, 200 kVA and smaller, with high voltage of 8,660 volts and below, are additive polarity. All others are subtractive polarity. The distribution transformer can be determined by looking at the transformer's nameplate. In this example, we're working with a transformer that has a primary rating of 7,970 volts / 13,800 Y and a secondary rating of 120 / 240. The primary coil voltage based on this nameplate would be 7,970 volts. Each winding on the secondary side produces 120 volts. Since the windings are in series, the output between the X1 and the X3 bushings would be 240 volts. The distribution transformer's KVA is also determined by the nameplate or the markings on the transformer itself. In this example, we are working with a transformer that has a rating of 25 kVA. Each winding on the secondary side produces 1/2, or in this case 7.5 kVA at 120 volts. Since these windings are in series, the output between X1 and X3 is 25 kVA at 240 volts. The secondary windings on the distribution transformer are shipped from the factory in series. The first winding has the terminals marked A and B, and the second is marked C and D. In order to utilize the full kVA of the transformer at 120 volts, we need to put the secondary windings in parallel. In this example, terminals A and C are placed on X2, and B and D are placed on X1. This procedure requires opening the transformer cover to access the terminals. As a side note, placing transformer windings in parallel is common when setting up a single-phase transformer for use in a three-phase bank. Thank you for watching this video. Feel free to email me at robert@graspcast.com or visit my website, www.grasscast.com.